Now consider this problem statement. So we need to compute the number of solutions for which this particular logarithmic equation is satisfied, right? Now here, so consider this equation as log x minus 1 in the argument base 4, that is equal to log of argument x minus 2 base 2, right? So we'll be solving for x and check whether the logarithmic factor must remain defined. So here this 4 can be written as, so in the next step I'll be writing this 4, this base 4 can be written as 2 square, so that the logarithmic base becomes same. That's why I am applying this particular logarithmic property, right? Now we know this property of log, which says that if I have something like this, that is log of, in the argument we are having a power p, let's say a power p, and in the base we are having, let's say, b to the power, let's say, q. This is the base. So the property says that the power in the argument, that is p, so that can be written here, and the power that is mentioned in the base, that is b power q, can be written in the form of numerator and denominator, and remaining terms as it is. So log of a base b. So I'll be exactly be using this particular property on this part. So in the argument we are having power 1, which is implicitly visible. So from this one we can write this one as, so in this very same step I can write, so here power is 1. So this can be written as 1 over 2. The argument will be 2 here, sorry, the base will be 2 here, and on the argument power, you write 1 or not, it is implicitly available, right? And now from this we can clearly observe that this 1 over 2, right, this 1 over 2. So we are also aware of this property, that if I have something like this, that is a times log of b, right? And let's say here base is, let's say, c. So in this case, this a that is multiplied with this logarithm factor can be written as b power a, right? So this quantity can be written on power of this b, right? So again I will be applying the logarithmic property. So this half can be taken on the power of this. So basically this is the square root, right? Now this log 2, this log base 2 is mentioned here. So we can cancel both of these terms, isn't it? The answer is incorrect. We cannot cancel this. Instead, we can say that by comparison, this particular quantity is equal to this one, right? So it is not because this log base 2 is cancelled, it is by comparison, right? So this is equal to x minus 3 because of the comparison, not because of cancellation, right? Now on squaring both sides, so this will be x minus 1, that is equal to x minus 3 squared, whole squared, right? So here on resolving this particular quadratic equation, we will be getting x square, and this is 3x. So this would be minus 7x, 3 2 is 6, right, plus 10, 3 3 is 9, plus 1 10, and that is equal to 0. And this quadratic can be factorized as 7 can be written as 5x plus 2x. So this would be x minus 2 times x minus 5. These are the two factors, and on resolving this we'll be getting x belonging to the set, that one will be 2 and the other will be 5. Now if you observe this 2, for this 2, if you observe, this 2 must be rejected. Why? Because this, if you observe 2 minus 1 on this logarithmic factor, on this equation, if you observe, sorry, this part, so 2 minus 1 is negative 1, and in the argument we cannot keep negative 1, so hence 2 should be rejected, right? But if you see 5 minus 1, that is 4 positive, 5 minus 3, that is 2, so the logarithmic factors remains defined. So here we can say that x will be equal to 5 because this 2 is rejected, okay, because of the domain issues. So from this we can say that the number of solutions is equal to 1. So in the hurry we can report the answer as 5, but that is wrong. Make sure it is not asking the value of x, it is asking for the number of solutions. So please do not report the answer as 5. There is only one real solution that can be accepted for this equation. So many times out of lack of time, or let's say due to time constraints, we might answer 5 due to the test time pressure, okay, but this is not 5, 1 is the correct answer. So please keep extra care for this thing, right? So this is the problem statement and its solution. If it is asking for x, then it should be 5, but the number of solution is 1, so therefore 1 is the answer.